Hello everyone, welcome to the second video lecture series on power electronics and its basics. So in the last session or the last series, we discussed about what is power electronics and its importance and what are all the types of power electronic devices. So in this series, let us discuss about the few devices and its operation as well as its application. So we are not going to go much deeper into all its operation, but we are going to see what it is all about, how it operates in a simplified manner. So now coming to the device thyristor. So thyristors are SCR or the silicon controlled rectifiers. A thyristor is generally a three-terminal semiconductor device that acts as a switch. So in the diagram, you can very well see that it is like a BJT which is connected back to back. So it is an NPN and a PNP transistor which is connected back to back, where two N terminals are connected together and the two P terminals are connected together. So all put together, you can see there are three terminals. One is anode, gate, and the cathode. So these three terminals comprises of the thyristor, and you can see the symbolic representation which is given here, that is a BJT. Here there is another BJT, and these BJTs are connected back to back. A PNP and an NPN transistor are connected back to back. Here the P terminal is the anode and gate is the common gate and cathode. So here there is a power supply given to it. So once triggered, it conducts current until the current falls below the certain threshold. That is nothing but the holding current. So coming to the operation of the SCR. An SCR generally has three terminals, which we saw now, and on applying a positive voltage to the gate terminal, which triggers the SCR, and it causes it to switch on and conduct current from anode to cathode. Once triggered, the gate signal is no longer needed to maintain the conduction. So this is an important point which has to be noted in an SCR as far as other devices are concerned. Because in an SCR, just you need the gate to trigger the circuit, which means that to turn on the thyristor, you need the gate pulse. And once you turn on, there is no necessity to maintain the gate pulse. It still remains in the conduction mode. The SCR turns off only when the anode current falls below the holding current or when the anode cathode voltage is reversed. So you can see here there is a polarity of voltage given. So anode is connected to P and cathode is connected to N. Only when this polarity is reversed, the SCR is said to go into the turn off state. So fine. So we saw what a thyristor is and why is it a silicon control rectifier and how it operates and what are all the terminals available in an SCR. Now the major thing is what are the applications of SCR? So here you can see that the major application falls like it is used in high power control applications such as AC voltage controllers, motor speed control, and high voltage DC transmissions, that is HVDC systems. And now let us move into the next device. And here the next device is nothing but a metal oxide semiconductor field effect transistor. The MOSFET is generally a three-terminal conductor device which is used for switching as well as amplification, which was not seen in the case of thyristor. In power electronics, MOSFETs are primarily used as switches due to their fast switching speed and low on-state resistance. So coming to the operation of the MOSFET generally has three terminals. You can see here in the picture, that is the gate, the source, and the drain. So again, here it is, these two are the substrate, N plus substrate, and this is the P base. So this generally consists of four terminals, but one terminal is not used actually. So this base terminal is not generally utilized here. So the gate, source and the drain are the major terminals. So hence it is called as the three terminal device. And on applying a voltage to the gate, the terminal controls the current flow between the drain and the source terminals. In enhancement mode, MOSFET is generally said to have a positive voltage on the gate and creates a channel that allows the current to flow easily. And coming to its application, they are used in switching power supplies, DC to DC converters, motor drives, and lighting control. They are particularly well suited for high frequency switching and applications in low to medium power ranges. So it generally used in high frequency switching, whereas the power ranges is from low to medium. So a small assessment question. Thyristor, name any one application of thyristor. Yes, so this is a trigger question for you. Let us meet in the next video lecture series. So thank you for now.